Hey there. In this video, we're going to talk about arithmetic and geometric sequences. So these are two special type of sequences that we like to deal with. First, we'll start out with an arithmetic sequence. In this type of sequence, the pattern of the terms is just adding the same amount to each term to get to the next term. So if I start out with 1 and I just start adding 5, or start out with 5, and I just add 5 to it repeatedly. So my terms are 5, 10, 15, 20, 25, and so on. That's an arithmetic sequence because each term is just 5 more than the term before it. So that 5 that we're adding each time is called the common difference for that term. And I can write the nth term of this sequence because I want to be able to find, say, the 100th term of that sequence without having to find the 99 terms that came before it. So this formula for the nth term will allow me to do that. All I need to know is what the first term of the sequence is and what the common difference is to get the nth term. So a1 plus the common difference d times n minus 1 will give me any term in the sequence without having to find all the others. Now, it's worth noting we can write this as a recursively defined sequence where you do use the previous term to find it. The nice thing about it is the nth term is a little bit simpler. However, finding terms can be more difficult unless you know all the terms that come before it. So if I write it as a recursive sequence, an would equal an minus 1 plus d. So you're just taking the term before it and adding the common difference each time to it. So that's how an arithmetic sequence works. Let's do an example. We'll take that 5, 10, 15, 20, 25, and let's come up with the nth term for it. So remembering that our general formula for an nth term, and this is what we would call the explicit one versus the recursive one, an equals a1 plus d times n minus 1. Now, if it might be that the common difference is obvious, like it was here, we could pretty clearly see, oh, we're just adding 5 each time. If it's less obvious what it is, you can find the common difference by taking any two consecutive terms, so any two that are back to back in your sequence, and taking the difference. Take the later one minus the one before it, and it will give you the common difference. So here I took the first two. 10 minus 5 tells me the common difference is 5. I could have done 25 minus 5. Or 20 minus 15, any of those will tell me what that common difference is, 5. And I already know that the first term is 5, so the nth term is going to be 5 plus 5 times n minus 1. And if you're wondering, yes, you can simplify this, but it's not necessary. The other type of sequence we want to look at is a geometric sequence. So with an arithmetic sequence, we're just adding the same value over and over again to get the next term in the sequence. For a geometric, we're multiplying by the same number each time to get the next term of the sequence. So that number we multiply by is called the common ratio, r. And the nth term can be described using this formula, an equals a1, so the first term, times r, the ratio, to the n minus 1 power. So these can be a little bit harder to spot sometimes just because of the multiplication factor there, but this is how we can find a geometric sequence. So let's do an example with this one. So we want to write the nth term of a geometric sequence. Now, we've been told it's a geometric sequence here, so again, you might look at this and say, gosh, that was not obvious. You can always test it out by trying to find a common ratio between a few different terms if you're not sure, and they don't tell you that it's geometric. So here, my sequence is 36, 216, 1296, 7776, and so on. I know it's geometric, so I know I'm going to use that formula, an equals a1 times r to the n minus 1. So I know a1 is 36. That's the first term of the sequence. I just need to figure out what r is. What is being multiplied each time to each term to get the next one? So with the common difference, we subtracted consecutive terms to find the common difference. To find the ratio, we're going to divide consecutive terms. So for instance, if I took 216 and divided by the term that came before it, 36, that will give me the common ratio, which is 6 here. If you're trying to verify that it's geometric, then I might do another pair of consecutives, like 7776 divided by 1296. And I should get the same number, 6, from that to verify that I am, in fact, dealing with a geometric sequence. Okay, so now that I have the first term and I have the common ratio, I can plug everything into that formula. So an equals 36 times 6 to the n minus 1. And if you're ever not sure, you can always test out your nth term by plugging in a value. For instance, if I plugged in 4 for n, that should find me the fourth term, which should be equal to the fourth term we were given, which was 7776. And that's how you find the nth term of a geometric sequence.